This slide shows you a production alternatives table and a corresponding production possibilities curve for a nation whose two production alternatives are coffee and computers. If you look at the table closely, you will see there's point A, which has 30 units of coffee and 0 computers, and this corresponds to point A on the graph below. Point B, with 28 units of coffee and 1 computer, corresponds to point B on the graph below. C, 25 coffee, 2 computers, point C on the graph. D, 20 units of coffee and 3 computers, point D on the graph. E, 13 and 4, point E on the graph. And F, 0 and 5, okay, and that is point F on the graph. If you look at the graph, you'll notice there's a green line connecting the two extreme points, 30 units of coffee with no computers, 5 computers with no coffee. If we were to calculate the opportunity cost based just on these two extremes, let's imagine this country is currently operating at point A. They have 30 units of coffee and no computers, and they wanted to have 5 units of computers. They would give up 30 to get 5. So the opportunity cost would be 30 over 5, or 6 units of coffee. Okay, that would be the entirety, a very rough approximation of moving completely from A to F. When we calculate increasing opportunity costs along a production possibilities curve, what we are doing really is approximating, right, little slices of the slope along this production possibilities curve. So if you're familiar with math, what I'm saying is the movement from point A to point B has a constant slope. Point B to point C also has a constant slope. C to D, D to E, E to F. In each case, between each set of 2 points, the slope is slightly different, and none of them will have the same slope as moving from point A to point F. Each of those little changes are going to be the opportunity cost, right, of moving between those 2 points. So let's imagine we're moving from point A only to point B. Right now we have 30 units of coffee and 0 computers, and we want 28 units of coffee and 1 computer. What do we need to give up? We give up 2, right, and we gain 1. So our opportunity cost is 2 over 1. Now I realize that's not technically the slope, because the slope is always, by mathematicians, defined as rise over run. But if we were moving from point B to point A, of course, we would be calculating the slope. But it is a constant change between A and B. So we're going to assume that if we only added, say, half a computer, right, we would just move halfway along this line, and we would have the exact same opportunity cost. Let's see how this works if we're starting at point F, okay, where we have 5 computers and no coffee, right? And if we want to move from point F to point E, so if we want to add 13 units of coffee and give up 1 computer, right, we give up 1, we gain 13. Our opportunity cost is 1 over 13, which is also the slope, well, negative 1 over 13. All right, but let's say now that I told you we only want to have 1 unit of coffee. Well, then we just move a little bit down this line, okay, but the slope here is the same as the slope from this whole section. So we can approximate what the opportunity cost is of 1 cup of coffee by saying, well, if we gave up 1 computer, we get 13. So if we only wanted 1 cup of coffee, we would just have to give up 1/13 of a computer. I hope that helps make sense of the fact that even though we're not always dealing with moving completely between 2 points, we can approximate the slope at any little change, any number of computers along the way, simply by figuring out what that change is to move all the way from F to E. All right, let's consider a few questions here. Same data. If the economy produces 2 units of computers, it can produce at most how many units of coffee? Okay, this question, all you need to do is locate on the table where are 2 units of computers. Right here, right, at C. So at most they can produce how much coffee? 25 units. Now let's do a few opportunity cost questions. It might help you to pause the video so you can try to answer these questions on your own and then check them. What is the opportunity cost of the 3rd unit of computers? Well, if we're looking for the opportunity cost of the 3rd unit, we must have how many right now? We must have 2. So we must be right here at production alternative C. What's the opportunity cost of the third unit of computers? Well, we would have to give up 5 coffees to get the third computer. So our opportunity cost is 5/1, or 5. What about the 19th unit of coffee? That one seems a little trickier, right? What is the opportunity cost of the 19th unit of coffee? We have 13, then we have 20. How do we know? How do we know what the opportunity cost is of the 15th or 16th unit? Well, look back to here. Remember, between 13 and 20, right? Between 13 and 20, this is a constant slope line. So all we need to do is figure out what the change would be if we went from 13 to 20 units of coffee, right? And then we'll know the opportunity cost. If we give up 1 computer, we get 7 units of coffee. So any individual unit of coffee we add between E and D has an opportunity cost of 1/7. All right, last one. What is the opportunity cost of the first unit of computers? If we assume we have no computers at all, we must be at point A. In order to get the first computer, how much coffee do we give up? 2 units. So the opportunity cost is 2. Now let's look at 2 separate comparative advantage problems. This one I think causes less problems for people because, as you can see, it is an output problem. As it says, this table shows the maximum amount of cars and clothing the US and Canada can produce if they only produce one good. So referring back to this table, these would be the 2 extreme points, the equivalent, right? The 2 extreme points, the 2 endpoints in the country's production alternative tables. And that's all we need to consider when we're calculating comparative advantage. So if the United States can produce 80 cars or 40 units of clothing, Canada 60 cars or 30 units of clothing. So what is the US's opportunity cost in terms of cars? They give up 40 to get 80. It's 1/2. Interestingly enough, it looks like Canada has exactly the same opportunity cost, right? If you look at this table right now, it appears to say that there is no advantage in trading between the United States and Canada. I didn't realize that when I typed this information. So let's change this for a second, and let's make this 20. Okay, then we have a little more interesting problem. So what is the opportunity cost in the United States if they elect to produce cars? You give up 40 units of clothing for every 80 units of cars, so the opportunity cost would be 1/2. What about if the United States elects to produce clothing? We have to give up 80 cars for every 40 units of clothing, so our opportunity cost is 2. So 1/2 here and 2 here. For Canada, we have to give up 20 units of clothing for each unit of cars, so the opportunity cost is 1/3. But you have to give up 60 units of cars for each unit of clothing, so the opportunity cost is 3. If you look at these, you should realize that the opportunity cost here, which is 1/2, right, is not quite as low as 1/3. So Canada, it looks like, has a comparative advantage in car production, and the United States in clothing production. The best alternative is for them to specialize according to this comparative advantage and trade. The next table actually has the same data, so I'm going to change it a little bit again. Did not realize that. And we are going to, we're going to get into this table and change this. This time we're going to make this, let's see, we'll make that number 20 hours. Okay, so I want you to look at the United States and look at Canada, and I want you to consider this input problem, right? These 2 countries, now we're finding out how much time it takes them to produce either 1 unit of cars or 1 unit of clothing. So the output is held constant. What's different is the time that it takes. So in order to calculate opportunity cost now, we have to consider how much of a unit would be given up. If we look, let's look at Canada first. Canada has 80 hours, takes them 80 hours to produce a car, or 40 hours to produce a unit of clothing. Okay, we can't just say, oh, if they produce cars, it's 40 divided by 80. That doesn't work anymore. What we have to do is we have to think about if Canada chooses to produce cars, it takes them, if you look down here at this little line, it takes them a whole 80 hours to produce 1 car. So the question is, how much clothing would they have given up in that time? Well, it only takes them 40 hours to produce a unit of clothing. So at 40 hours, they've already got 1 unit of clothing. By 80 hours, right, they would have had 2 units of clothing. So Canada's opportunity cost, if they produce cars, is going to be 2 units of clothing. Okay, so I'm going to put 2 right here. If I put it in the box, it sometimes does a weird thing. Okay, what if Canada chooses to make clothing? And erase this line. What if they choose to make clothing? Well, it only takes them 40 hours. How many cars would they've gotten done? They would only be to here. They would have only gotten halfway through making a car. So Canada's opportunity cost there would be 1/2. So calculating with inputs is a little bit different, right? It forces us to really think through how much of a unit would they have gotten done. See if you can do this. Pause and see if you can calculate the opportunity cost for the United States. The answer is this. If the United States takes 60 hours to make a car, they would have gotten 3 units of clothing made in that period of time. And we can see that by looking at this. Okay, they've got 1 unit of clothing, right? 2, I guess my number line didn't work out too well here. Okay, and then 3. So they have a total of 3 units of clothing they could have made in that period of time. Okay, I'll make my 60 hours look a little bit longer there. Didn't measure those out too well. However, if they choose to make clothing, it only takes them 20 hours. You can see they would have only been 1/3 of the way through making 1 car. Okay, so now let's look at our numbers. Those are our opportunity costs. Who has a lower opportunity cost for clothing? The United States. Okay, because their opportunity cost if they make clothing is only 1/3 of a car, whereas Canada's is half a car. Who has the lower opportunity cost for cars? Canada, right? Because they give up 2 units of clothing, but the United States gives up 3. Hopefully this clarifies it. As I said, there will be some practice problems on Moodle that you can do to further work on your skills on calculating opportunity costs.